For years, AI in medicine has felt like this distant promise, right? Something always just over the horizon. But as of early 2026, that's all changed. The promise is here. We're in the middle of this fundamental shift where AI is no longer some research experiment, but a true clinical coworker, working right alongside the healthcare team.
And this quote right here, it used to sound like something you'd hear at a tech conference, all futuristic and aspirational. Not anymore. Now it's simply a description of what's happening right now. The future we were all waiting for, it has officially arrived.
And this is the key takeaway I want you to get. The old way, the era of just experimenting with AI as some kind of fancy chatbot, that's over. We have entered a completely new phase. We're talking about deep structural integration. AI is now being woven into the very fabric of healthcare as a true clinical coworker.
So what's driving this huge change? Well, it's not just about more powerful AI. It's about a different kind of AI. We're seeing the rise of these models that are capable of something called verifiable System 2 reasoning.
Okay, System 2 thinking might sound a little academic, but the key idea here is this thing called a thinking trace, and it's a total breakthrough. Think about it. Older AI models were what we called a black box. You'd put data in, you'd get an answer out, but you had no idea how it got there. These new systems, they can literally show their work. This lets a doctor follow the AI's logic step by step, from a symptom all the way to a diagnosis. I mean, that is a complete game changer for building trust and ensuring safety.
So let's look at some of the key players that are shaping this new landscape. You've got models like DeepSeek R1, which is a rock star at that transparent chain of thought reasoning we just talked about. Then there's Claude Opus 4.6, which can basically remember a patient's entire medical history during a single consultation. And this last one is so important. OpenBioLLM. The magic word here is open source, which means hospitals can run them on their own private servers. Huge for security. To put that number into perspective for you, a 1 million token context window, it's absolutely massive. It's the difference between an AI that needs constant reminders and one that can grasp the full, complex story of a patient's health journey all at once. That capability alone fundamentally changes the depth of AI-assisted diagnosis. And this solves the one giant problem that's been holding back AI in medicine for years, that trade-off between performance and privacy. Now, hospitals don't have to choose. They can get state-of-the-art AI while making sure that sensitive patient data stays completely secure, right there, within their own walls. So we've seen the tech behind the curtain, but what does it actually do in the real world? Let's look at how all this code is translating into clinical results that are impacting patient care right now. I mean, just look at these numbers. It's wild. Using a traditional stethoscope, primary care doctors identify serious heart disease less than half the time. But with an AI-enabled digital stethoscope, that number skyrockets to over 92%. That is more than double the accuracy. It's an incredible leap in diagnostic power. And it's not just stethoscopes, not by a long shot. We're seeing new AI that can analyze sleep data to predict diseases like Parkinson's years in advance. It's revolutionizing medical imaging, allowing for a much deeper understanding of scans. And it's being built directly into the electronic health record systems that doctors use every single day. We're also seeing the rise of these so-called agentic workflows. Here, the doctor gives the AI a high-level goal, and the AI agent just goes to work, navigating databases, filling out forms, and pulling together data. This totally shifts the doctor's job away from all that tedious data entry and moves them toward high-level intellectual oversight. But you knew this was coming, right? All of this incredible new power brings with it new responsibilities. This whole revolution isn't just about the technology. It's about the evolving role of the clinician and the new duties that come with it. This all sounds amazing, doesn't it? But really, what's the catch? With this much power getting integrated this quickly, there have to be new challenges and some new rules of the road. And there are. The FDA is classifying some of these tools as administrative aids, which basically puts the full legal responsibility for validating their output squarely on the doctor's shoulders. New laws are requiring doctors to disclose AI use to patients. And it all boils down to this new principle, algorithmic stewardship. This brings us to a really critical human challenge. Doctors have to actively fight against automation bias. That's that natural human tendency to just overtrust what the computer says, even when it might contradict their own clinical judgment. The AI is a powerful consultant, for sure, but the doctor has to remain the final authority. always.
So with all these new tools and all these new rules, how can a doctor practically use this in their day-to-day work? Well, let's walk through a simple but incredibly powerful workflow that any clinician can start using today. It's being called the Do I Yourself workflow. A doctor can take a dense, jargon-filled clinical study, upload it, and just ask the AI to translate it into simple, patient-friendly materials. You can ask for a summary, some interesting facts, even an outline for an infographic.
And the impact is just staggering. A task that used to take a doctor close to an hour of painstaking work, translating all that complex science into understandable language, can now be done in less than 2 minutes. This is how you give hours and hours back to clinicians.
And this leads to a really powerful conclusion. Understanding how these AIs work, their strengths, their limits, their privacy safeguards, it's no longer an optional skill. It has become a core competency for doctors, just as essential as knowing how to use a stethoscope. We've really crossed a threshold. The experimental era is definitively over. AI in medicine is no longer a fascinating novelty. It has become a fundamental piece of clinical infrastructure, as vital as the MRI machine or the electronic health record. So if AI really is the new stethoscope, the ultimate tool for listening to the human body, we are left with one crucial question. Are we prepared for everything it's about to hear?